In this video, we're going to talk about functions. So the first thing to know is a relation, and a relation is simply a set of ordered pairs. So that can have any relationship between x and y, or in our case, a and b. So that means a set of points. It could be a curve like this, it could be a parabola, it could be a line, it could be a circle. Those are all relations. But a specific type of relation is what we call a function. So a function is a set of ordered pairs in which each x element, so something over here, has only one y element. We call that a one-to-one. So this is a function because each one of these x elements has a corresponding y. But this is not a function over here because if we see this one has two outputs, which makes it a relation but not a function. Something else that we can find within a function and a relation is the domain and range. So the domain is all of the x values that make that function or relation true, and the range is all of the y values that make that true or real. So you can see that from a graph, and you can actually solve it algebraically as well. Typically, if it's a function that doesn't have any restrictions along its domain or its range, is what we call all real numbers. So if I wanted to find the domain of this function, f of x equals x squared plus 5x algebraically, what I'm going to first do is look for any restrictions that might cause this graph or this function to skip any spots on the x-axis. So I'm looking at this and it doesn't have anything in the denominator, so what I'm going to say is that the domain here is going to be all real numbers. And we can use set builder to denote it like this, or we can use interval notation to denote it like that. And also looking at the graph of this function, I know that there aren't any restrictions here, there are no gaps, and it's going to keep on going to negative infinity that way and positive infinity that way, so the x-axis is going to hit all real numbers. So let's take a look at an example where I do have our variable in the denominator. So I have f of x is equal to the square root of 3x plus 12 all over the quantity of x minus 5. Now, what I know about a denominator is that it cannot equal 0. And what I can do is I can set this up. I can add 5 to both sides. Simply put, x cannot be 5. But something else to note is I have a radical here. Now remember, the domain and range have to produce real outputs or real numbers. So although I can have a negative under a radical, that's not a real number. That's a complex number. That's imaginary. So what I then need to do with my 3x plus 12 is say that it's got to be at least greater than or equal to 0. I'll solve that out. So I find that x can not be 5, and it also has to be greater than or equal to negative 4. And this is the way that I'm going to express it using set builder, which is essentially those two things, throw it in all real numbers. Or I can use interval, where it would contain the negative 4, and it would go up to 5, not include the 5, and then skip over that value, and then start at 5 again, not including it, and go to positive infinity. Alright, and here's the graph of my function, and it proves what I just found, is that my domain has to be greater than or equal to negative 4, which starts right here, and it's going to go down, and it's going to have this asymptote right here, which is a point on the x that my function will not ever reach. So it will approach 5 here, it will never touch it, and it will approach 5 coming this way as well, but it will never touch it. So that's why it doesn't include the 5, but it will go on to infinity that way. Alright, and last but not least, let's talk about operations with two functions. So let's say I have f of x here and g of x here, and what I want to do is I want to express the sum of these two things in this way. So we use the notation of f plus g, which is just the function f plus the function g, and then our input for both is x. So I'm going to set it up like this. So all you have here is just this guy plus that guy, and I'm going to simplify it. And here's what I end up with here. I skipped a couple steps, but I think you guys can fill that in. So I'm going to also do the same thing here. I'm going to set it up, and you've probably guessed it. It's going to be 1 over x plus 2, but minus my g function, x minus 1. So I'm going to do the same thing, solve it out, and this is what I get here. Now you can probably guess with the same functions, and if I have f times g, I'm going to set it up like this, times x over x minus 1. I'll skip a couple steps and I'll solve it out for you. And by skip a couple steps, I mean not at all, which just gets rid of the 1 here. And now let's just do that here with f over g, so that's going to be 1 over x plus 2 all over x minus 1. And I'm going to multiply by the inverse of the denominator, and I get x minus 1 over x times the quantity of x plus 2. Alright, and that's going to do it for this video. Thanks for watching.